You're supposed to find the area bounded by these two functions between negative pi over 4 and pi over 6. So we got to graph these. These are almost the regular graphs of sine and cosine, except for the amplitude is changed and the sign is flipped over. So I'm going to graph them. I'll graph this one in red and the other one in green. I don't know if you can see the green well, but whatever. We have... I have to go back to negative pi over 4, so I'm going to have something like this. The sine function, normally that would be like this. However, it's flipped upside down because of the negative, and it's also, the amplitude is changed to 2 instead of 1. So it goes all the way up to 2, it goes all the way down to negative 2. Okay? So we have that, so it's flipped over. I'll just do it both ways. Whatever. And so that's, I didn't even do it in red. And then to cosine, normal cosine looks like this. Right? Just by the way I drew sine, it looks like this is 2 pi, this is pi. Yeah? So if I draw cosine, it's going to start up at the top. In the middle, it's down here. Crosses there. Crosses there. Ends up there. And then we okay? And this is 2 cosine x. Are we all right? Yes. Okay, so then we have from negative pi over 4. Well, what is this? This is pi over 2, right? So pi over 4 is right here. So that means negative pi over 4 is, whoa, look at that. Do we see that? It's probably going to be, actually, it has to be. The only time sine and cosine are equal to each other is at pi over 4, because they're both root 2 over 2. Right? So at negative pi over 4, since we change the signs of the other one, I mean, they have to be equal here. Are we okay with that? If we couldn't figure that out, if we couldn't figure out just by looking at it that this is negative pi over 4, you could always set them equal to each other, right? To find out where they intersect, you can set them equal to each other. So if I were to do that, I don't need to now because I already know, and I could figure it out in my head. But if you couldn't figure it out, the way that you figure out when two functions intersect is by setting them equal to each other. So if I did that here, I would get negative 2 sine x equals 2 cosine x. I would divide off by 2. So I get negative sine x equals cosine x. And then here, you know that both of them are equal at pi over 4. So any version of pi over 4 will get you a root 2 over 2, maybe negative or positive. Sine is already negative. So then on the unit circle, the only way we get negative cosine, or negative for cosine would be here or here. Negative root 2 over 2, and it just happens at, wait a minute, no. If we wanted to make the sign negative, then it would change to a positive, right? I'm just using the fact that they tell me the negative pi over 4 part. So then right here is where they're equal. It equals each other in other places too. It's just we only want as far back as negative pi over 4. Do we understand how to figure that out? Yes. Okay. So then x would be negative pi over 4. I'm going to undo that, go back to my graph. that means I need the area from like in between here, which is the bigger function, to cosine x, right? And I'm going all the way until pi over 6. Oh, that even... Where's pi over 6, do you think? Smaller than pi over 4? So, we're actually looking for this area. Right? I don't even need to know where it... Because they don't intersect. I don't need to solve for anything. I just stop at pi over 6. And I know that pi over 6 is smaller than pi over 4. So, that's where I put it. We okay with that? So now I can do the integral. I only have to do one integral, which is nice. And it's from negative pi over 4 to pi over 6. And bigger function minus smaller function. So if I have the integral here, negative pi over 4 to pi over 6. 2 cosine x minus the smaller. Any questions on this? I'll take a 2 out just because I want to. Antiderivatives, this would be regular sine x, because the derivative of sine is cosine, plus negative cosine x, right? This is the same case, Jessica. Like, the derivative of cosine is negative. I don't want it to end up as a negative, so I just add in a negative. All right, the derivative of negative cosine would be negative sine times another negative, so that would be positive sine. Evaluated from negative pi over 4 to pi over 6, and I have the 2 out front. I guess I'll leave the 2 out front. That's fine. And then I have sine of pi over 6 is 1/2. Yeah? Cool. Minus cosine of pi over 6, that's minus root 3 over 2. Minus sine of negative pi over 4 is negative root 2 over 2. Minus negative cosine, that's root 2 over 2. What? For this and this?
No, the cosine. Or you put like minus negative red.
Wait, let me. So I have maybe. So this is when I plug in pi over 6. This is when I plug in negative pi over 4. So I get a negative there. So just the one negative, yeah. And then cosine of negative pi over 4 is still root 2 over 2. I got it. So then this is a bunch of stuff. Plus, plus, plus. So we just have pretty much root 2 at the end, because the 2's will cancel. And then 1 minus root 3. Both of those over 2. Multiplied by 2. So then I just get 1 minus root 3 plus 2 root 2. Is that right?